Hello, this is lesson 9-2 and it begins on page 141. Here we are going to derive the quadratic formula. And so it begins with previously you learned that solutions to the general quadratic equation ax squared plus bx plus c can be found using the quadratic formula. You can derive the quadratic formula by completing the square on the general quadratic equation. Alright. So here's what we want to do. We want to go ahead and take the general quadratic equation, ax squared plus bx plus c. And we want to set it equal to 0 and solve for x. The challenge here is that instead of using numbers, we're using letters. This looks like a nice challenge. So let's go ahead and begin. Alright. So the first thing we want to do is make the coefficient of x squared 1, so we have to divide everything by a. And so what we get is x squared plus b over ax plus c over a is equal to 0. Now we can go ahead and draw our square and begin to complete the square. So first of all, x squared always goes in the top left, where the dimensions are x and x. Here is where it might get tricky. We have b over ax. And is c over a part of my diagram? Nope. So we have to move it to the other side. So let's go ahead and subtract c over a, and we get x squared plus b over ax equals negative c over a. Remember, what we did is we always took the coefficient of x and we divided it by 2 in order to fill in these two areas that are always going to be the same. Here, what we need to do is, since we have b over ax, we need to take b over ax and divide it by 2. Now, when you simplify this, what this actually turns out to be is b over 2ax. And that is what goes in these two boxes, b over 2ax and b over 2ax. So now, when you add these together, it gives you b over ax. So what we need to do next is find the dimensions on the outside. X times what gives me b over 2ax? Well, it's going to be b over 2a. Since this is a square, this dimension is also b over 2a. And then finally, when we multiply these together, we get b over 2a squared. This is what completes the square. So let's go ahead and add that to both sides. Whatever you do to one side, you have to do to the other. Alright. Now, again, this represents the area of the square, x squared plus b over ax plus b over 2a squared. We can write this equation differently. Since that represents the area of the square, we can use the dimensions on the outside. And so it's simply going to be b over 2a squared. And then we can simplify this. We have negative c over a. And let's go ahead and multiply these together, and we have b squared over 4a squared. So when we square b over 2a, this is what we get. Now, let's go ahead and we have two fractions here. Let's convert it into one single fraction. So what we need to do in order to have it into a single fraction, we need to have the same denominator. Notice that this denominator is 4a squared and this denominator here is a. What I can do is go ahead and multiply this fraction by 4a, both top and bottom. Now when I do that, just writing everything else here, 4a times negative c, well that's negative 4ac. And notice the denominator now becomes 4a squared. And then I'm just writing everything else. Now, as you can see, I have the same denominator. That means that I can go ahead and combine the numerators. Now, this is just a preference. I want to put b squared first and then minus 4ac. And then, since the denominators are the same, I can just write it once. Alright, that's what we have so far. So now, we finished completing the square. Now what we need to do is solve for x by taking the square root of both sides. So if we take the square root of both sides, we get x plus b over 2a. Now since this is a fraction, I can take the square root of the numerator, and I can take the square root of the denominator. Now we can simplify the denominator. B squared minus 4ac. The denominator, if I take the square root of that, it's going to be 2a. Because, let me just go through this step by step. Since I have two factors here, I can take the square root of 4 and the square root of a squared. And the square root of 4 is 2. The square root of a squared is just a. Alright, so what I can do, rewrite this whole thing. B over 2a is equal to the square root of b squared minus 4ac all over 2a. Finally, one last thing to do. Oh, by the way, since we took the square root of this fraction, we have plus or minus. Finally, what I need to do is solve for x simply by subtracting negative b over 2a. So we have x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Again, because these two fractions have the same denominator, I can combine them together. And so, putting everything together, I get negative b plus or minus b squared minus 4ac all over 2a. There we go. This is the quadratic formula. And we solved this by completing the square. So, why is the quadratic formula important? Well, we're gonna use it for lesson 9-3. So in lesson 9-3, which begins on page 144, we're going to solve quadratic equations using the quadratic formula, and then later we're going to use the discriminant to determine the nature of the solutions of a quadratic equation. So if we go ahead and take a look at number 1, solve each equation by using the quadratic formula. For each equation, write the number of solutions, tell whether the solutions are real or complex, and if real, whether the solutions are rational or irrational. So again, let me go ahead and write the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a is equal to x. Okay. Notice we got this from the general form, ax squared plus bx plus c equals 0. So in order to solve this quadratic equation using the quadratic formula, notice that I need to find a, b, and c. And as you can see, a is always the coefficient of x squared, so a turns out here to be 4. B is the coefficient of x, which is 5. And c is simply the constant, the number with no variable, which is -6. It's very important to make sure you include the signs. So now all we have to do is simply plug this into the quadratic formula. So we have x is equal to -b, well that's -5, plus or minus the square root of b squared, well that's 5 squared, minus 4 times a, which is 4, times c, which is -6, all over 2 times a, which is 4. Now what we need to do is just simplify everything. And so x is equal to -5, and I want to go ahead and simplify everything underneath the square root. So we can use a calculator for this. First of all, 5 squared is 25, minus 4 times 4 times -6. That didn't turn out right. 25 minus 4 times 4. This isn't working out. 4 times 4 is 16. 16 times -6. 16 times negative equals -96. So 25 minus -96. 25 minus -96 is positive 121. Okay, that took a while. 121. All over 2 times 4, which is 8. By the way, what is the square root of 121? It's 11. So -5 plus or minus 11 over 8. Plus or minus simply means we're going to have two different answers. So x is equal to -5 plus 11 over 8, or x is equal to -5 minus 11 over 8. -5 minus 11 is going to be 6. 6 over 8. Finally, this simplifies to 3 over 4. So one of my solutions is 3 over 4, or -5 minus 11, which is -16 over 8, and this is -2. There we go. How many solutions were we able to get? 2 solutions. Real or complex? How do I know if I have a complex solution? You know you have a complex solution if you have I. Do I have I in my solutions here? Remember, I is equal to the square root of -1. Did we get a square root of a negative number here? No, we got the square root of a positive number. So we have real solutions. And if they're real, how do I know if they're rational or irrational? Here's a very simple hint. If it's rational, then my answers are going to be either whole numbers or they're going to be fractions. So I do have rational solutions. How do I know if I don't have a rational solution but an irrational solution? A very simple way to tell if you have an irrational solution is if you have the square root of a number that isn't a perfect square, such as 3. Notice here we have the square root of 121, and 121 was a perfect square, which means it came out to a whole number. If you do have the square root of a number that isn't a whole number, then you have an irrational solution. Alright. So as you can see, we use the quadratic formula in order to solve our solution, to find our solutions. So let's keep on doing some more. And, let me erase it up to this point right here. Alright. Okay, so here, again, we want to use the quadratic formula. Notice that this is A, this is B, and this is C. So if we go ahead and plug it in, let me use a different color here. This is A, B, and this is C. So plugging it in, we get -5 plus or minus the square root of 5 squared minus 4 times -2 all over 2 times 4. Let's go ahead and simplify this. We have -5 plus or minus square root 5 squared. We have 16 times -2, which is -32. I guess we'll use some math here. 16 times -2 is -32. 25 minus -32 is going to be +57. All over 8. So my two solutions are -5, and notice 57 is not a perfect square, so I'm just going to leave it as the square root of 57 since I can't simplify it any further. And then my other solution is x equals -5 minus square root of 57 over 8. So can you see how this plus or minus consists of two solutions, where one is positive and the other one is negative? So my solutions are right here. How many solutions do I have? I have 2. Are they real or complex? Well, did I have the square root of a negative number here? Nope. So my answers were real. And now since it's real, is it going to be rational or irrational? Well, I can tell if it's rational if I have fractions or a whole number. Notice that I do have something that's set up like a fraction, but it's going to be irrational because I have the square root of 57. 57 is not a perfect square, so that makes it irrational. Okay. So once you start getting the hang of this, you can see how the quadratic formula has its benefits. So let's keep on doing the rest here. -4 plus or minus the square root of, and I'll do this fast, b squared minus 4 times 4, which is 16, ac, which is 1. And so here we have all over 2a, which is 8. If we simplify this, we get -4 plus or minus the square root of 0 over 8. And so we get -4 plus or minus 0 over 8. So one of my solutions is -4 plus 0 over 8. And x equals -4 minus 0 over 8. If we simplify these, -4 plus 0 is just -4. -4 over 8, which is -1/2. And if we do the other one, -4 minus 0 is just -4 over 8, which is also -1/2. How many solutions do I have? Or let's write the solutions down. -1/2 and -1/2. Number of solutions. Well, technically I have 2 solutions, but they're the same, so we just say one solution. Are these real or complex? Well, did I have the square root of a negative number? No. So they're real. Rational or irrational? Well, do I have whole numbers and just whole numbers and fractions? Yes. They're rational solutions. Notice that when we took the square root, the square root of 0, well, that's 0, so it's technically a whole number, so it worked out. Finally, let me just erase this. Let's do the last one. So again, using the quadratic formula, -4 plus or minus the square root of 16 minus 4ac, so 20 times 4 is 80. I'm just doing this really fast. You can just pause the video if you need to check it. All over 8. So let's go ahead and simplify this. 16 minus 80, I hope. Yeah, -64. Okay. So x is equal to -4 plus or minus square root of -64 over 8. Now we can simplify this. What is the square root of -64? Well, notice that if we take 64, it is a perfect square. And so we can put 8, and then what we're left with is the square root of -1. And we cannot forget what the square root of -1 is. The square root of -1 is I. So we have 8i over 8. Again, we have two solutions. We have -4 plus 8i over 8, and then x is equal to -4 minus 8i over 8. So here are my solutions. My solutions are these right here. There we go. How many solutions? I have 2. Are they real or complex? Since I have I and I had the square root of a negative number, they are complex solutions. Now, because they're complex solutions, I can't answer the last question. Only when it's real can you answer if it's rational or irrational. Alright. Alright. So we did all of that. The discriminant of a quadratic equation ax squared plus bx plus c equals 0 is defined as the expression b squared minus 4ac. The value of the discriminant determines the nature of the solutions of a quadratic equation in the following manner. So take a look at this table, and the discriminant is b squared minus 4ac. Let me write the quadratic equation again. -b plus or minus square root of b squared minus 4ac all over 2a. Do you see the discriminant anywhere in the quadratic formula? Here it is. The discriminant is simply underneath the square root. Why is the discriminant important? Well, let's take a look at all the all the ones that we just found, and let's highlight the discriminant. As you can see here, here's my discriminant is 121. For question B, my discriminant was 57. For question C, my discriminant was 0. And then for question D, my discriminant is -64. Now, how do I know these are the discriminants? Well, remember, when I looked at my quadratic formula, my discriminant was simply whatever was underneath the square root. Whoops. There we go. That is my discriminant. It's everything underneath the square root. Simple as that. Alright, let's take a look at number 7. Compute the value of the discriminant for each equation in item 1 to determine the number and nature of the solutions. So if I were to just do these questions again by only calculating this discriminant, so again the discriminant is b squared minus 4ac. So this is b. Let's just label these. This is b, this is a, and this is c. if I were to go ahead and calculate the discriminant, well, it's kind of a pain because we already did this. B squared minus 4ac, but didn't we already do this? Yes, we just did this. Here it is again. 5 squared minus 4 times negative 6. Exactly same thing I have here. So let's just look back at our original ones. When we did this, it turned out to be 121. So discriminant is 121. And notice these are the same questions as all of these we already did before. We don't have to do it again. We just have to point them out. So here the discriminant was 57. For C, the discriminant was 0. And then for D, the discriminant was negative 64. Now let's look at the table. B squared minus 4ac. Okay, so when B squared minus 4ac, when the discriminant is greater than 0, and B squared minus 4ac is a perfect square. So let's take a look at these. Which one of these is greater than 0? Well, this one is greater than 0, and this one is also greater than 0. Is 0 greater than 0? No. So this one isn't it. Is negative 64 greater than 0? No. Now, what is the second part? B squared minus 4ac is a perfect square. Which one of these are perfect squares? It's going to be this one. This is a perfect square. Okay, so this is greater than 0 and it's a perfect square. If it falls under these conditions, then the nature of the solutions are two real rational solutions. Is this what we found out? Yes, we said that they were real, they were rational, and we had two solutions. So the table is simply telling us what we already found out. But the table is helpful. So if we just simply look at the discriminant, looking at the table, we can tell that we're going to have two real rational solutions. Now let's go ahead and take a look at this. B squared minus 4ac is greater than 0, and B squared minus 4ac is not a perfect square. Well, we already determined that this is a perfect square. Is 57 a perfect square? No, not a perfect square. So if it's not a perfect square and it's greater than 0, then we're going to have two real irrational solutions. Is that what we determined here? Yes. We found out they were two real irrational solutions. So the table is definitely being consistent. Now let's take a look at the next one. B squared minus 4ac, the discriminant is equal to 0. Which one is equal to 0? Well, it's C. So this one is describing A, that one's describing B, and this one's describing C. And if it's equal to 0, then it's one real rational solution. Is that what we found out here? Yes, we had one real rational solution. The table is very consistent. And finally, if B squared minus 4ac is less than 0. Which discriminant was less than 0? Well, this one. This one is less than 0. And what does the table say? You have two complex conjugate solutions. Conjugate. Here we have two complex solutions. And by the way, what do we mean by conjugate? Well, let's rewrite these two solutions as two different fractions. negative 4 over 8 minus 8I over 8. Now this is something that we learned in a few lessons before. Conjugates are simply where the imaginary part simply has the opposite sign. So here's the real part. The real part stays the same, but the imaginary part, the sign changes. And as you can see, we go from positive to negative. And yes, these are conjugates of each other. So two complex conjugate solutions. So the table is very consistent. And guess what? If we were just interested in finding not the solutions, but the nature of the solutions, if they were how many solutions we had, how many, if they were real or if they were complex, and rational or irrational. If we're just interested in finding this information, we need to use the quadratic formula to find our solutions and then determine the rest? No. What we can do instead is find the discriminant. And so let's just do these really quick. We're not interested in finding the solutions. We're just interested to see if how many solutions we have. Are they real? Are they complex? And if they're real, is it rational or irrational? So let's go ahead and find the discriminant for each of these. So simply using this, b squared minus 4ac, b squared, well, that's going to be 5 squared minus 4 times 2 times 12. We have to do some math here, which is 25 minus 4 times 2, which is 8. 8 times 12, well, 8 times 12 is 96. And I can already tell that this is going to be a negative number. It's going to be negative 71. Here's my discriminant. Is 71, negative 71, is it greater than 0, equal to 0, or less than 0? It's going to be less than 0. So the discriminant is less than 0, which falls under this case right here. Let me just erase everything here. It's going to be this condition, so that means that we're going to have two complex conjugate solutions. There we go. I spelled that wrong. Conjugate solutions. There you go. We just found the nature of the solutions without even solving the quadratic equation. Just by looking at the discriminant, we can find the nature of the solutions. We have two solutions, they're complex conjugates. And that's why the discriminant is important. So I leave it to you to finish number 8. And that's all there is to it. Thank you for watching.